All right. Well, I think I'm recording everything correctly. I want to be honest. These Mondays always creep up on me. I'm deep into a doc right now, retrospecting. So I've been writing all day, not coding. But we did do a lot of coding and debugging last week. I feel like I left everybody kind of on a cliffhanger, wondering if we were going to be able to solve all of the errors in the Kale contract. So people are using LaunchTube. They're using it at an astronomical rate, which is very exciting. Let me bring up that chart really quick. And I know this is quickly becoming the Kale chat, but hey, it's the Coding with Kale Pale, and guess what I've been coding? Lots and lots of Kale contract stuff. Trying to keep LaunchTube alive, trying to keep the contract alive. Had some big updates, both on the contract and on the LaunchTube side last week. I am very hopeful that this week, once I finish this doc and kind of dust my hands of it, I'll be able to move on to some Kale utility items. I'm working on an AI thing that I keep talking about. I'm very excited. Maybe, if we get enough time, and you guys promise not to spam it, because I'm going to have to, if I'm going to share my screen, maybe there's a way to share the screen without sharing the URL, because it's heavily rate limited. I haven't put in a whole lot of protections on it yet. I would really love to show people, but they have to promise not to send it 800 requests, because then all my services would crash and I wouldn't be able to keep testing it. So I don't know if I can trust the community to not like, well, yeah, but it's me. I'm special. And I really want to try it. And I understand when you see it, you'll want to try it. And I know I do. But I might be able to find a way. I think Discord's added enough, maybe, to where I can share my screen without sharing the URL. I'm not sure. But maybe I'll just trust you. And if it cracks, I'll just change the URL or something. I don't know. But anyway, let me share my screen. Speaking of all the reasons I don't want to share. What does this say? Windows, screen, or app? Make selection, because I think you can you choose what to share a device, make selection. If I click, no, it would share still shows. Wait, what's this? Share all windows, presenter overlay. Yeah, I think if I share the entire screen, obviously the entire screen, and this is the piece. Doesn't Safari hide the URL, or is there like a? Well, you can obviously see this, but isn't there a way? I know in Safari, I think it might hide and only show the tab. Maybe in Chrome, there's a way to, maybe if I go full screen and then, might be able to do that. It's a bit risky, but maybe we'll try that later. Okay, so this is you guys can see this, right? Nice. So this is our graph right now. I think last week we left it somewhere on the way up. Yesterday we hit our new all-time high. We finally crossed 200K invocations, which is absolutely bananas. That's crazy. I set a goal for 100K in the first quarter. I did not think we'd be hitting double that just a couple days later. So burn it to the ground. Keep it going up. This is amazing. If we look at the leaderboard, I think we crossed 1,000 wallets on the leaderboard, which is amazing. Oh, and everybody's gonna be like, yeah, but a bunch of those are zeros. Like, I understand we hit zero at like 824. That's fair, but still 823 with some kills. I'm pretty excited about that. But anyway, where was that? I know we looked at this graph too. Sorbonne. I want to look at the fee stats in a minute. Let's look at the network adoption. There's a graph. You guys are getting a nice little inside peek. You can remember last week we were hitting all these errors, and you can notice kind of over here on the right side we fixed something, and that's what I want to talk about today. Is what we did to fix the errors, because essentially, well, let's describe what was happening. Someday I actually need to build a graph for what was happening here, but let me make a new file. Essentially, the way that Sorbonne works is you've got a transaction. In that transaction are several things. First is just, can we look at a transaction? Probably be the easiest thing to do, right? Let me pull this over here. Usually, looking, I'm a visual learner. Let's actually look at the Kale contract, see if we can find, let's look at a plant. Here's somebody that's planting. Let's look at this transaction. This transaction will go over to laboratory, API Explorer, get transaction. That's an RPC. Let's just look up transactions, single transaction. This is on mainnet. Submit that. Let's look at the envelope XDR for that. A hop, skip, and a jump, and there we are. So inside of a Sorbonne transaction, you've got a couple of different things. A Sorbonne transaction can only have one operation. So oftentimes when you hear me or others talking about a Sorbonne transaction, you, being the astute observer, may think, but you mean operation. Technically, we mean both, because you can only have one Sorbonne operation in a Sorbonne transaction. So that's worth keeping in mind. In classic operations that are not of this invoke host function type of operation, you can have up to 100. I think there are a couple other Sorbonne invocation types, operation types. And for each of those Sorbonne invocation types, you can only have one of those operations per the transaction. There's a reason for that. It's not a throughput concern. It's a parallelization concern, where we want to open up the ability for Stellar to operate in parallels, where we can increase the TPS by a tremendous amount. And some of that requires, though, the way that these transactions are constructed, one of those things being only one thing can happen per the transaction. So anyway, the actual transaction, one of these Kale transactions, so this is actually more of like a launch tube thing. Oh goodness. Is that a fee bump, all these transactions? So you'll notice all of the Kale, all of the launch tube rather, transactions all get paid by this tube account. So this is the fee account. But in order to ensure really high throughput with LaunchTube, we have lots and lots of sequence accounts which pay the sequence number. So they don't pay any XLM to get the transaction on the network. That's what Tube is paying for. It pays the fee, and then the sequence number pays the sequence number. This allows us to kind of have this channel accounts logic where we have really high throughput, but we don't have to have a lot of accounts with XLM. Just one account with XLM paying the fee and a bunch of accounts that pay the sequence number. So that's cool. And it also, one of the nice things, or one of the reasons that I'm super excited about, or why LaunchTube is working so well, is that inside of a Sorbonne transaction, the only thing that I actually need in order to get your transaction on chain is like the operation itself. I don't need anything on the outside. I don't need to know what source it is. I don't need to know what account you've got. I'm going to include my own account here, my own account here. All I need you to send me to LaunchTube is the operation itself, which will include things like authentication. When you're not dealing with a Sorbonne operation, you may borrow the signature from the operation or from the transaction in the operation by having the source account be like null in this case, which makes LaunchTube a little bit harder, where you have to sign something, and then if I change the source account, I can't change the source account because you signed for that source account. So it makes it a little bit trickier to use something like LaunchTube for non-Sorbonne operations. Obviously, there's still ways to do it, but it works really, really well for Sorbonne operations where these smart wallets or these C accounts can't pay fees. So you're going to need some way to get them on chain. So somebody's got to have a G address in order to pay the fees. LaunchTube handles that for you. All I need from you is just the operation. So inside of a Sorbonne transaction, in this operation, we've got several components. The first is just what contract are you calling? The next is what function are you calling on that contract? So in this case, it's the Kale contract with the plant function. And then it passes an array of arguments. So in this case, it's an address and an amount. So if I were to pull up, and I will really quick, pull up the plant function, you'll see that it's got these two arguments. It's got the default just environment. This isn't something that you pass. It just comes for free. But the arguments that it passes, the things in that array I was just looking at, are the address, so in this case the farmer, and the amount, which is what you're seeing here, the farming address and the amount, in this case, that's being staked for this particular plant, for this farmer. Okay, so that's the first bit. That's like the components of the function, what the contract is, what the function name is, and what the arguments are. And then you've got this authentication piece, and this is what makes the magic of LaunchTube work so well, is that you can sign for a Soroban invocation completely separate from the transaction, where in classic Stellar you can't do that. If you're going to sign for something in the operation stack, it has to go inside of this signatures box. And then you have to borrow for it inside of the operation sources. So when you have an operation for a payment, you can change the source that you require the signature for, but then it goes inside of this signatures box, which then makes it actually pretty difficult for me as LaunchTube to ensure that this transaction that I'm like fee bumping and paying the fee for is actually signed appropriately, right? I could sign part of it, but then if you've got a bunch of operations that have their own source accounts, I've got to be like, well, I paid my part of it, but you're going to have to finish it. You're going to have to finish signing it. I will blank check, submit whatever you send me, but we have to do a little bit of coordination if I'm going to give up a sequence number account for this. And then I've also got to watch that you aren't like putting one of your sources as my fee source or as my sequence source, because then you could steal all of my sequence money. Because I'm going to blank sign this collection of operations, but I'm not sure that I want to do that because I'm not really sure. So now I've got to like look at all the operations and make sure that your source account isn't my sequence account, which I can absolutely do. But there would need to be at the very least some back and forth coordination of this like pre-signed or partially signed transaction before I could finally submit it. We could absolutely do that. Maybe sometime in the future I will. But the nice thing is with Soroban, you don't need this because the authentication can happen entirely separately from the outside body of the transaction. Now, it doesn't have to. You'll notice inside auth, and this one actually has it. Great. This one actually has it. Where credentials is just this little string source account. If your credentials for your auth, and you'll notice that it's an array, so there can be lots of different signatures for an invocation. If one of the credentials is source account, it is borrowing the authentication of the outer transaction. So it's borrowing the signature of this address here to sign for this authentication. So my guess is, in this particular instance, or not my guess, I'm absolutely certain that I did not, my account, this BHGM, will be the same as this BHGM here. I'm not using my own sequence, so this is not a LaunchTube sequence address. Whoever submitted this transaction to LaunchTube is not simulating. I'm not doing any simulation for them. So this account is paying the sequence number, and they also have to sign for themselves because inside of this Soroban auth entry, it's borrowing the source account as its credentials. If you were to look at, let's look at another one, see if we can find another one that doesn't borrow, you'll notice that the credentials is its own whole body. Let's look at one that's maybe a C address instead of a G. There we go, here's one. Let's look up another transaction. Let's look up the envelope XDR for this one. If we go down into the operations, we close up the invoke and we look at auth. This time credentials is a whole body, right? Instead of being a string of just source account, it's saying, okay, we got a lot of stuff going on here in order to generate an actual viable signature to authenticate this particular invocation. And in this case, it's a smart wallet. This smart wallet is going to include things like a nonce, so it has like its own sequence number. It's got its own expiration and its whole own signature. So like what we had down here, right? I'm going to be simulating, I'm going to be using my own LaunchTube sequence account to sign for this transaction. It's not going to pay any fees. That's what the outer tube account is going to do. But then this is a sequence number account that I'm using inside of LaunchTube, but you're not borrowing, or in this particular instance, this invocation is not borrowing that signature. It's generating borrowing that credential. It's creating its own. In this case, it's got its own C address that it's signing for. It's got its own signature key. This stuff doesn't need to make a whole lot of sense to you. If you need to know more about that, you can learn in my passkey kit, because that's what I'm using. This is probably a WebMiner invocation. What do you mean automated? Yes, that's exactly correct. Yep. So in my case with the WebMiner, I'm using G addresses on the website as a secondary signer on your passkey wallet. And then the browser just holds that secret key in local storage, I think, or maybe a session key, a session storage. And then it signs with a G address. But instead of that G address being on a Stellar transaction, it's a Soroban auth entry, because I've added a G address as a signer to this smart wallet. You might have thought incorrectly that smart wallets equal passkeys as signers. They don't. You can have a SecP256R1 passkey signer as a signer on your smart wallet, but you can also have G addresses, and you can have whole contracts be signers. It's very, very cool. You should definitely check out the passkey kit that I've made and that we're actively developing and using. Passkey kit for all of your passkey needs for the things that I'm working on in that arena. But anyway, you can kind of see that happening at work here inside of this Soroban invocation, where you've got a whole custom signature section separate from the transaction signature. So at this point, with a fee bump, oh my goodness, every time I click it, with a fee bump and a transaction and a Soroban operation, there's actually 3 signatures going on, right? One is for paying the fee. So this is the secret key of the tube on LaunchTube. This is the secret key of the sequence number account. And then we've got the secret key or signature of the actual Soroban auth entry for this particular Soroban invocation. And it's just got the one. I mean, I could have done multi-sig if I wanted to, but I just need one signature for this one. And that's the body. That's actually the whole of the operation. We haven't even started getting to the whole footprint thing yet. So let's do that now. We get to the footprint. So that's like once you get through operations, if you spend any time in Classic, you're like, yep, I mean, it kind of makes sense. It's definitely more complex. You know, there's a lot more stuff in here than in a Classic operation, right? I thought we were just dealing with destination and amounts. Yeah, we're doing a lot more because we got smart contract stuff, but it's just an operation at the end of the day, an invoke host function operation. And I just love that smart contract Soroban, it's not an L2, it's not another network. In fact, it's just another operation on Stellar. It's a magic operation because it can do anything. But it's just Stellar at the end of the day, and it is also Stellar. It's amazing. But once you start moving into this extension component here, this is when things start to get a little bit more gnarly, or at least very interesting. And this is where we're really starting to explore what the future of Stellar is going to look like, with the inclusion of this footprint, or really all of these resources, where you've got footprints, and then you've also got instructions, read bytes, write bytes. This is where we're going to enable the ability to do parallel transaction execution, because in the footprint, you are explicitly, like part of the transaction, before it goes and it tries to do anything, you are making explicit guarantees to the network about what you intend to do, what you intend to read, what you intend to write, and how much you intend to read and write, and the number of CPU instructions. And this is amazing because it will allow parallel transaction execution, where as long as 2 invocations are not going to cross these ledger keys, you don't have to then worry about like double spend, where I'm spending 10 and spending 10, and I only have 10 to spend. Oops, I just went negative, right? This is where we can't do parallel transaction execution. We have to do serial because we have to line everything up, because if you're going to touch this ledger entry, I need to make sure if you're going to touch it again in the future, like the 10 and the 10, when you only have 10, I have to execute those serially so that, oh, you just spent 10, that means you now have 0. And so if you try to spend 10 again, that's negative 10. So everything has to be executed in serially. But if you made an explicit statement about what ledger entries you're actually going to be touching, what balances, what contract entries, all of the ledger storage, you're making explicit guarantees about what you're actually touching. Now you can say, okay, so long as there's no crossover between these ledger entries, we can then execute those in parallel. And this will be amazing for the future. I'm incredibly excited about the future that we have, where we finally get to make use of the pain and suffering that we've been put through to actually make explicit statements about our footprints, and we get to get the computational and cost benefits of doing this. But it does also make it a little bit easier to read and reason about what your invocation is about to do. So even outside of the parallel transaction execution benefits, you kind of get some wallet benefits too, where a wallet can then surface what entries it's about to touch, what the current value is, what the new value would be, without ever having to really do any sort of like simulation. They can just look at the entry and say, oh, you're about to do something big with this entry. Maybe you shouldn't do that. Or you could simulate without actually having to like execute or run some sort of weird L2 network. You can just run a basic simulation against the current state of the network, see some big change that's about to happen to that entry, and alert your user on a like a wallet front. So that's pretty cool. Let's go through the actual components here. One is a read only, and then a read write. So read only, I mean, this is pretty basic, right? I'm not going to change the entry here. I'm just going to read it. So this is a really safe field in the sense that it's blockchain data. Anybody could read it anyway, so I'm not trying to protect anybody. It's just going to cost something, potentially. If you include an entry here and the entry exists, you are going to have to include enough read bytes here in order to cover whatever that field, the number of bytes that it is. So you'll notice that I actually have to read the contract data. I think I might write the contract data. Let's see here. Yeah, I write it right here because I'm including block information. You can see like the actual, this FAIGWA, when you see me looking for that one, that's the actual contract for Kale. So you can see a read write here on the ledger key contract instance. So that's all of your instance storage. If you've written Rust Sorbonne contracts, you know there's 3 types of storage: instance, persistent, and temporary. Well, instance is a persistent entry that's just a special type of storage, like an object storage that's stored on the actual contract instance. And I'm both reading and writing that contract here. You can see that because it exists inside of this read-write array. You can see one here called contract code. So I actually need to read up some contract code, which is coming from this hash. You can see I'm also doing the same thing to whatever contract this is. Maybe it's a cross-contract call to a Stellar Asset contract. I don't actually think that's true, but there's quite a few of items here in the read-only section, and there's also some in the read-write section. Elliot, did you have a question? It's fine if not. All right. I don't like us. The reason I say I don't think this is a Stellar Asset contract is Stellar Asset contracts don't have WebAssembly files that you have to read. They are host functions, so you don't have to go and read them from storage. But usually when you see, every time you see contract code, it means it's reading in some contract. Boom! That's what it is. It's a smart wallet contract. I was like, I'm not exactly sure what this would be, because one of these is the actual contract code for the Kale contract. This one would be the smart wallet. Excellent. Well done. There's a few of these items here, but the important thing to remember is, well, two pieces that I'd want to bring out. One is read only, and then the second one is read write. Now, you're going to get confused, like I did, probably, unless you're smarter than I am, which is possible, but we'll assume you're not, is that these things like map to each other. That these read bytes is about this footprint read only, And the write bytes map to the read write bytes. And if something exists in one, it's gonna consume these bytes, and if something exists in the other, it's gonna consume those bytes. That is not at all true, and your first clue for that is that this says read write, and so it will both read and it will write. The only additional thing that this will do is write, and so certainly this write bytes is going to be included in this read write, but it is not true that these two things map to each other. And that definitely tripped me up some when I was trying to solve the particular bug that hopefully eventually we'll get to. But you have to think the entries that I include in here will be read, as well as the entries in here will be read. So whenever you include any ledger entry into the read only or the read write, it will increase the size necessary for this simulation or for the read bytes required. So that's worth like keeping in mind. The read write, it's going to be similar in that any entry here is going to be written. That will be you'll have to simulate that to figure out exactly the amount of data that's being written. I think I'm convinced there's some sort of difference between whether you're writing or you're updating. It may just be the resource fee, that it's cheaper to update bytes than it is to create new bytes. I'll have to do more research into that. Simulation, I'm going to be honest, I was really disappointed in simulation a week ago. I'm really impressed by simulation at this point. It does a great job. I was just stupid, and now I'm smarter, and I'm super happy about that. But simulation is an amazing tool. The engineers that wrote this and keep it up to date and make it fast, super impressive, because it's accurate and it works, and that's amazing. There's probably some improvements that can continue to be made. There always is. But I thought it was broken, and it's not. I was broken. My code was. Okay, so that's the read only and the read write section. The other thing to keep in mind, and this is critically important, is the difference of like what is being read and what is being written. Like what is actually costing me when I'm talking about read bytes and write bytes. These are ledger keys. These are not ledger entries. A ledger entry is the thing that you will be charged for. And so you pass it a key, and ironically, or maybe obviously at the end of the day, a ledger entry includes both the key and the data. So when you pass this is not what is being read. It's part of what's being read. It's just the key. It does not include the data. The footprint does not include the data that's being written or the data that's being read back. And that's really good, because if this was part of the footprint, you'd have to explicitly declare what data you were writing in the footprint, and that might change based off of your contract logic, and it could become very difficult to simulate that. The only thing that needs to be static in order to ensure that the contract logic isn't changing is that the key itself, like the key value, is static. So like if you're using dates or ledger numbers in your keys, that's going to be a problem. But you can use dates and environment sequence numbers, like things that are variable in your values for those ledger entries, because those are not included in your footprint. And this is going to become incredibly important when I start talking about the bug again, the difference between the data, like what you simulate and what you submit. Hopefully everybody's tracking okay. So the ledger key is the thing that you pass, but the ledger entry, which includes both the key and the value, that's what will consist. That's what you're going to need to simulate, or that's what you're going to need to include when you start talking about read bytes or write bytes. It writes both the value and the key. The key is included in the ledger entry, but it is not the sum total of the ledger entry. That one really got me. I thought it was like the ledger, you have a ledger entry has a ledger key and a ledger value. You are not writing a ledger value, you're writing a ledger entry. The ledger entry includes both the key and the value and the expiration sequence and an extension code. It includes some additional information. So if you want to know how many, if you're trying to like craft a footprint by hand, if you know what the key size is and the value size is, that's not enough. You have to put them together into a ledger entry XDR, I guess. And those bytes of that XDR will be the size that will be required for the read bytes and for the write bytes. Okay, so we're making good progress. I'm not going to talk at all about instructions. That one is a lot easier to reason about when you're actually simulating or you're testing code in Rust. There's just a cap. It is what it is. Don't go over it. As far as like the resource fee, that's all going to be some goofy factor, mathematical calculation based off of how much you're reading, how much you're writing, how much you're updating, blah, 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 blah. Simulation gives you that back. Just use what they give you. And if it doesn't work, call Dima. I don't know. Someone will fix it for you. Increase the number. This is actually going to become a real issue and one that I think we're going to need to think a lot about as we're hitting a lot of surge pricing, which again, we'll talk about in a minute. Okay, so I think it's time to actually talk about the bug itself. We've gone through what a transaction looks like, its components, this extension part, the footprint and what we read and what we write or read and write, and then how that relates to the read bytes that you'll need to include in your budget and the write bytes. You also, the reason that you include these explicitly is you have to pay for these regardless of whether or not you use them. The way that core works is basically there's a set limit to how much resource can be used in a ledger, and then it looks at all the transactions that are coming in requesting to be included in a current ledger, and it basically asks the question, how much write bytes and how much read bytes and how much instructions are you requesting? It looks at that on a per transaction level, and then it also looks at a per ledger level. And so if your transaction pushes it too far above, or I think at all above the ledger limit, it'll punt you to the next ledger and continue to punt you until either the RPC just drops it, or the transaction expires. I think those are the two main reasons that could get punted. So keep that in mind. Another good reason to keep your resource usage as low as possible. It will give you a much greater chance of getting included into the ledger that you request or the ledger that you submit your transaction into. But once you hit surge pricing, there's no guarantee that the ledger that you submit your transaction into will be the actual ledger that it executes in. It could go much further. That's one of the reasons it's really important to set a max time on all of your transactions, so that you have some sort of ability to reason about, do I think that transaction will go through? It definitely won't if the time has expired. And so I set all of mine to 60 seconds. And then on the Launch2 backend, I basically say after 60 seconds, I can safely assume the transaction has failed if it hasn't come back as successful. Because it gets a little wonky when it's just sitting in RPC or sitting in core, waiting to like churn through surge pricing. Many times, and this will be where we get to our resource fee, when you hit surge pricing, transactions are more expensive to be included. And so if you included a resource fee that worked when you simulated, but doesn't work when it actually comes time to execute it because of surge pricing, you may have a resource fee that just keeps punting your transaction further and further out. Maybe it'll get executed at some point. Maybe it'll never get executed. But unless you include a max time, you're going to have a hard time knowing, is it safe to like resubmit or not? So keep this to something reasonable so that you know when I can be absolutely sure that transaction that I'm not really sure where it's at definitely will fail because it hasn't been included. So I need to resubmit with a bigger resource fee, a larger resource fee. So I said we'd talk about that later. We just talked about it now. Mark that off the list. Okay. Couldn't wait. Let's move to the actual bug here. So there is an issue, and this is the issue. There's this like getting a Sorbonne, getting smart contract invocations online is a 2-step process. Well, kind of a 3-step process, but the last one's pretty simple. The first one's simulation. The second one is submission, and then it's like this status, success, or failure. And this is where you're like pinging, right? You're doing get transaction, get transaction, get transaction. And it says not found, not found, not found, not found, success, or failure, or whatever, right? That one's pretty straightforward. The part is just that in between submission and status is a bit of a question mark. But right now, let's talk about simulation. So simulation takes into account the current state of the ledger. So let's consider Kale, right? We've got blocks that are executing. Block 1 executes, then we close and open a new one. Block 1, 2, 3. And eventually we get to you who wants to participate. You're super excited. And the time has passed, right? So there's 5 minutes that pass in between each block. And then the next block is allowed to be opened. And so what happens is between block 3 and block 4, 5 minutes goes by. You're planting, you're working, you're harvesting, having a wonderful time. And now it's time for a block switch. It's been 5 minutes. It's time to have a block switch. And so everybody goes and they say, hey, looks like 5 minutes has passed. I'm ready to run plant. Plant is what you use to kind of express interest in the process of getting a reward for this block. In order to get a reward for a block, you have to plant, and then you work, and then you harvest. That's what you have to do in order to get a reward for a block. The first thing that you have to do, though, is plant, to open and express your interest, and then at some point after plant, you submit work, and then after the block closes, the next block opens, block 5. Now you can harvest the block -1, whatever it is, block n-1. So that would be your ability to go back and harvest for block 4. So you may choose to, when block 4 opens, right, if you participated in block 3, you may choose before you plant to harvest the previous block. I don't recommend that. I would say you probably want that in here because it really is high priority. The sooner you plant, the higher your reward will be whenever you go and work, because there are those 3 variables. And gap is one of them. The amount of time between when you planted and when you work will contribute to the amount of kale that you are going to get for that block. So it's kind of paramount that you plant as soon as possible. So let's go ahead and assume that this is the order of things that you wanna do. When you plant, everybody, because of what I just said, everyone who is kale farming wants to plant as soon as possible. And so when we were originally seeing this bug, and it's much higher now, or this issue, I won't call it a bug, this issue is we had more than 200 individual farmers that were all trying to do the plant at the exact same time. And so when they ran simulation, they all called plant, and plant looked at so simulation looked at the current state of the chain, ran the simulation on the plant function, ran the code for it to kind of see what do we need to craft that footprint into, what ledger keys do we need, how many read write bytes do we need. And so it took a look at the current state and basically said, looks like it's time for block n+1. And there's 2 things that have to happen in this plant. There's 2 branches of logic that happen when you plant. And one is there's block n+1. And so this would be like create block n+1. And the other one is update block n, whatever the current block is. And so when we simulate, all of these 200 plus are going to get this particular logic branch, create block n+1. Everybody simulates for this. And so it builds a footprint that basically puts inside of read write block n+1, which we'll say is what? That is block 4. So everybody gets read write block 4. All right, that's awesome. Actually, no, that's terrible, because you can only create a new block if the time has passed. And so only one of these 200 plus is actually going to be able to do this read write block 4. Everybody else has to update. And this is the normal flow of things. If you weren't part of this original simulation, is you're going to run this simulation is going to see, it's not time for a new block yet. You just need to read write block 4, right? We're not block n+1, we're just block 4. So this would be all everyone else. And this is going to be true for the people who simulated, but also true for everybody else who comes. Now, at first blush, this is like a big problem, but then all of a sudden you realize, oh no, this actually is fine, because n plus 1 is 4, right? Currently, when it's simulated, it was block 3, and it's time to punt, it's time to bump it. And so it's going to create n plus 1, which is, let's see, 3 plus 1 is 4, so they're going to need to create block 4. That's going to put it in the read-write, because it doesn't need to read it, but whatever, it needs to write it. So it needs to write block 4. Everybody else also needs to write block 4. And so they both have the exact same footprint. Even though it's a different branch logic and they simulated differently, the actual footprint's identical. They both have to read-write block 4. But hopefully, as I'm walking this through, you can see exactly where the issue is. The issue is that the whoa. How do you spell write? Oh my gosh. W-R-I-T-E. Thank you. Oh my goodness. How embarrassing. Write bytes for this particular block is what? It's 0. Why is it 0? I'm sorry. I didn't even need to write. It's read bytes. Because it's in the read-write footprint, it doesn't need to read it. Because does block 4 exist yet? No, it doesn't exist yet. So the read bytes for this block 4, are 0. But what happens in this case where I need to update block n, which is actually block 4? I'm going to need to read the number of block bytes, which in my case is 460 bytes. I know that because of the pain and suffering I went through last week. I need to read 460 bytes. So my footprint is fine. Everything's looking fine and dandy, but I need to read 460 additional bytes in order to execute the invocation for a simulation that was like incorrect. It's simulated on the wrong branch. This is a bit nuanced. It's like super obvious once you see it right in front of your face. But when I'm trying to debug this, as you know, thousands of transactions are failing with this error. Read bytes is insufficient. Read bytes is insufficient. I'm just like, I don't understand why it's insufficient. It's a simulation issue, but they both have the same read-write. Like, they should be reading it. Why are they not reading it? The reason they're not reading it is because that block didn't exist when they were simulated. And so even though it was in the footprint, it read that ledger entry. It said, all right, we read this entry. Guess how many bytes there are to read? 0. So we don't need to read any of these things. It's all good. And I'm simplifying things a little bit because there are more things to read and write in this block, things like the has pale, which is also something that is stored. And so there was some nuance there, some other additional changes that we made that made it even more confusing when I was initially trying to debug this, where sometimes I would see 460 was missing, sometimes I would see 240 are missing. And that was the difference between storing a pale, reading a ledger entry versus reading a ledger key. There are some nuances there, but at the end of the day, it became much, much easier to rewrite the contract once I understood what was actually going on here in the difference between the simulated branch and then the executed branch and what was missing. And so with this understanding, I'm going to pose it as a rhetorical question. What do you think we should do in this case in order to ensure that even if, I can't not have everybody, all 200 people only one person simulate, everybody else wait until that ledger is passed. How do I make sure, no, in that ledger, let everyone submit. And they need to be able to have a simulation that's like wrong, but will actually turn out to be right when they actually go and instead of creating the block, they update the block. The only thing I really need to do, right, is ensure that this read bytes is included at an additional 460 bytes. So I need to somehow trick simulation into including an additional 460 bytes in this simulation, which probably, it actually will mean that for one person, they're going to have to pay for an additional 460 bytes that they won't actually need. But then for the other 200, or the other 199, I guess in this case, they will use that additional 460 bytes. So the way that you do this, or the way that I did it, we'll go over to the contract code here. Here are my two branch logics. Here's the if the ledger timestamp is greater than or equal to the current timestamp, or I'm sorry, the if the current time is greater than or equal to the saved farm block. So if it's been, in this case, 5 minutes, then we go ahead and we create a new block. Otherwise, we need to read the block, and then we need to update it, or have that block so that we're able to begin to set any changes on that particular block. So it includes things like the amount that you staked, so that we need to keep track of the total staked amount so that we know what the amount of kale I should give each person, and I don't like oversell my kale in a block. So there's like things that we have to update and store. But that's true whether we're creating a new block or we're updating an existing block. The big difference being if all of the simulation happens in this branch, there's nothing here to read, assuming this isn't here, there's nothing in here to clue in to actually include an additional 460 bytes so that when the actual logic executes on those transactions that mis-simulated, they're going to read get block and not have the necessary bytes to actually read that get block. And so the way that we solve this is we run get block inside of this branch on the previous, like before we n plus, right? So in this bump farm index, that's where the index gets n plus 1'd. So before we do that, we read the previous block. So this is where simulation is going to simulate an additional 460 bytes, but it won't actually use it. And then when get block runs, it's going to run off of the index. Now, what's kind of interesting in this particular case is that this get block is actually running on a different index. So even though it says index here, this index is going to actually be the index n plus 1. And the get block in this one is going to be a read on an older block. But it won't matter, because in this particular case, it's going to be reading a block that's yes, n plus 1, but it'll be borrowing the get bytes that it simulated when it actually ran on this during simulation. So it includes an additional 460 bytes that it doesn't actually read when it is executing, because it's not executing on this branch anymore. It's executing on this branch where it actually uses those 460 bytes. So now the obvious question is, okay, but you included like the old index, the old block in the get, so it's in the footprint. Yes, it is in the footprint, but this one's going to be in the read-write footprint, where this one is only in the read footprint, and so it will read an additional 460 bytes that we'll never actually use. So it's like a wasted footprint block, but the actual read bytes don't ever get used until it's actually executing on the alternate branch. So it's a little bit of mind gymnastics when you're thinking through, okay, what happens if, really just two, but if 200 people try and run this particular branch in simulation all at the same time? How do I ensure that when they actually go to execute their simulation, that it will still pass even though it was like mis-simulated? And that is basically the sum total. Like, I beat my head on a wall for days, and all I needed to include was this. It took a lot of pain and suffering, and I'm very hopeful that we'll take some learnings from this, and we'll do two things. One, we're going to write like some documentation that is a bit more of a full spectrum example on how to sort this stuff out so that we don't end up in these types of situations where you build at least if you do end up in a situation like this, you know how to reason about how to like trick simulation into giving you more bytes when the actual execution branch. Like, again, it's that tricky thing of what's the difference between simulation and submission, so that what you simulate, even if it's not exactly what you submit, you can still succeed so long as it has the right bytes or the right footprint, I suppose. And the other thing that I'd really like to see us as, instead of actually having to do something like this, where you're including more information than you need in your footprint, we could get something like env dot add read bytes 460 or something like that, right? So we don't have to put anything in our footprint. We can just include additional things in simulation for the read bytes or the write bytes or CPU to avoid issues like this. Or maybe you could even include like block, ledger, or something or other, right? So that it would know how many bytes it needs to include, and it's a bit more dynamic than just hard coding. I would love to see something like that added. There's some conversation about maybe putting something in the metadata for the field, something add additional CPU or memory or CPU or read bytes, write bytes, but that's a little bit blunt. I don't want to penalize every single person to have to pay more bytes than they need to. I'd really prefer to be more fine-tuned than that, right? There's only one branch logic, and it's a pretty rare one, relatively. Only one person is actually going to kind of suffer from having to pay an additional 460 bytes. Everybody else would have had to pay the 460 bytes anyway. So I'm willing to like penalize for that. I wouldn't necessarily want everyone to have to pay that. So anyway, all of that to say, that's how we solved it. Are there other ways to solve it? I don't know. Figure it out. Write your own contracts, or maybe try and tweak this even further. Most of the time, this isn't going to happen. This is kind of unique to where every single person on planet Earth is potentially trying to change the state, and then everybody else has to read the changed state. You really want to try and avoid stuff like that. It's kind of like the idea of growing vectors. It's impossible to simulate if something is growing, even if it's like, well, it's not eternally, it's not like unbounded, it's still bounded by whatever parameters, or maybe it's paginated or something. Well, that may be true, but if the whole world is trying to update something and read something all concurrently, you have no idea what the current state or the number of bytes that will need to be read or written if you're hitting the kind of concurrency that Kale is hitting right now. So you've really got to think about more than just you could run out of resource, and more be thinking, are users going to be able to simulate accurately these like logic branches that I'm creating in my contract? All right, cool. Well, I think that is it. Doesn't look like we have any questions, other than Raheem got confused just like I did when I was trying to write and really just needed to read. But hey, it's Monday. Chill. All right, so let me I'm going to pull, gosh, how am I supposed to do this without, I'm going to try this. Hold on. Okay, if I pull this out and then I say full screen and then I say full screen and then everybody close your eyes. Wait, I think I can do it this way. Ah, sweet. All right, perfect. Okay. Oh, shoot. Well, thanks a lot, Chrome. So close. Okay, nobody's allowed to use it. I'll have to change URL, whatever. This is what I'm working on this week and probably for a while. I'm writing an AI thing, and because I love you guys so much, I want to share it with you. It's heavily rate limited, and so all of that to say, if you start using this, you'll probably have to wait an hour to get any sort of response, and that's because it's using a lot of different AI models, all in series right now. I don't have parallel transaction execution on my AI generator. But I love pixel art. I love it so much. I grew up on, Duke Nukem, and there's one called Wacky Wheels, which is like a really pixelated, I don't know. I just loved pixel art. We had a really old cathode ray tube. We used to sit in my parents' bedroom and just like play on this thing on the floor. We didn't put up on a table. It was just on the floor, and very nostalgic for me, as is for many people. The issue is I'm a programmer. I'm terrible at making pixel art, and I don't really want to learn. I just love to enjoy it, and I love that there are pixel artists out there. So this was a bit of a problem when I made Colorglyph way back in the day, in that I love to collect pixel art, but in order to collect it, I had to trade it, and nobody really wanted to trade for my pixel art because it was garbage. So then you're like, well, I guess I could make it where people can buy pixel art, but then they've got to spend money, and that is definitely going to slow some people down, so I don't love that. So I tried to create like some logic for, you can buy colors and give the colors, and then you can get royalty payments. So even if you're not a good artist, and I think that's still viable, and I'm really interested in that. It's just pretty expensive to do all the royalty payments and keep track of like how many different colors are in a pixel art and who are the specific owners of each of those individual colors. There's ways to do it. It's quite expensive. And at the end of the day, it's kind of still like, I just want to make a lot of really cool pixel art. But there's like still that problem of how you're supposed to do it. I've tried doing it with AI, and AI sucks at making good pixel art, except for Pixel Lab. Pixel Lab does an incredible job making pixel art, and it's not even like a little bit better. It's way better, and they can go all the way down to 16 by 16, which is incredible to me. They start getting really good at 32 by 32, and then as you scale up from that, it just gets better. So I'm using that. I'm going to go ahead and type in a prompt because this frankly takes a very long time to go through all of these things. And if you all have sniped my URL, it's probably broken and it won't work anyway. So don't do that so that this can actually work. Let's do big red dragon fighting a brave shiny knight at sunset by the beach. Okay. A big shiny crab. Let's do red. A big red crab fighting a brave shiny knight at sunset by the beach. I'm not sure what shiny is going to come up with. So that's our prompt. That's what the image is going to try and generate. But I was not satisfied with images only. I've always had this dream. I have the domain smol.xyz, smol. I love small art, whether it's music, visual. I just like small things. And so do most people. And so I have this vision in my head of creating, I'm calling them artistic terrariums, where you've got these little encapsulated, beautiful pieces of creativity, and you're sharing them with the world, and people can collect them and bridge off of them and put them into mixtapes, things like that. But part of that would be music. I have been getting a lot into Suno.com. I think it's Suno.com. Which is just like AI generated music. I use it a lot when I play video games with my friends. I'll really quickly make a soundtrack for the last game we played, just like hazing them for all the ways that they dropped the ball. And then I'll play it for them while we're waiting for the next game, and it freaks them out. And I love it so much. We've used it for the kids in like helping them out with school. I made a toothbrushing song that's like instructional, that gives them instructions on how to brush their teeth, and it runs for like 2 minutes. It's amazing. Like it changes a lot for the way that I think about creativity and the ability to express all the things in my head through artistic forms that I don't have the talent for. All of that to say, there's another box here we can include for generating lyrics and music. Now, the sad part of this is I have no idea how to make sure that you guys can hear what my computer is saying. I think there may be a way in Discord. I'll have to look. And then if it doesn't work, I'll just leak the link because there's not too many people in here. So let's do a heavy driving electric guitar solo and drums. And we'll see what happens. So let me click generate on that. And then again, hopefully nobody's pending anything. It's a bit tough to run all of these. But essentially what it's going to do is take the prompt, send it through an AI model to generate the image through the Pixel Lab AI. And then it will send it through another AI model which takes an image and derives a description. So it will then describe the image, and then it will take both of those things, the prompt and the description, and send it to a lyrics AI model, which will generate a collection of lyrics. And then from those lyrics, it'll send those off to AI Song Generator. That's a terrible crab, but that's fine. It looks like he's got a guitar, which is also very interesting. Kind of seems like the crab is sneaking up behind him, and I still kind of love it. One of the reasons that I love AI, and I think this is where people get kind of upset with AI, is they want to use it as if it was their skill set, I guess. But AI is its own artist, and it hallucinates. It tries to do its best, and part of me really loves that, the unknown of what's about to happen when you click enter. and people can like, that's not what I meant. I didn't want him holding a guitar, and they get upset and they try and reprompt it and they get angry at the AI trying to get it to tweak and put the crab where they want it. And you're kind of like trying to do a little bit too much. Some of it does come down to just better prompting. The AI is doing the best it can, but the AI is a program. It's not an actual human being. And so you've got to work with it. And sometimes I do love its hallucinations because, like a child, where you describe something to it and it's like, wow, that I had no idea that what I said came across that way. It'll generate something that's quite artistic and has a really unique take on what I originally described. And that's one of the things that I'm excited about when you get like a bunch of these collections and lots of people making these things, is you almost invert the role of the creator is now the computer and the sorter organizer is the human. And now we're kind of curating and collecting and trying to find, it's just interesting. Different kind of like social dynamic where the artist is the computer and the compiler is the person. I think that's really interesting and something that I'm looking forward to exploring a little bit more. Okay, so it generated the image. Now it generated the description. The image features a man standing on the beach holding a guitar and looking out at the ocean. I wonder if it ever mentions anything about a crab. It doesn't. So who knows what kind of song this is going to generate. Crimson Clash at sundown. Heavy metal, driving electric guitar, powerful male vocals. Now I got to see, if I play this, you probably can't hear this, right? Yeah, so let me see if I think if I stop, can I edit screen sharing? More options. I feel like there was a way, share stream audio. Now if I click, does it make any difference? I mean, that's pretty wild for artificial intelligence, and generates two. Pretty similar. Ooh. So, I mean, I just love it so much. I'm not an artist, and I certainly am not a musician. And with a very basic prompt, just a couple of words, didn't even try that hard. I didn't get my crab, but I got a wild, sick beat. And so now, right, you create a bunch of these, you assemble them into a Driving Electric Guitar Solo Sunset album, and now we'll create, lo-fi beats study albums. I'll create Minecraft collections. You'll just create funny hallucination mixtapes. You'll send them to your friends. This like, I love AI so much for this type of thing where all of these things that I would have loved to do as a kid, but I just didn't have the time or the talent or the exposure to be able to learn these things and do them myself. I can, like, are they amazing? No, but they're still pretty funny, and they're not terrible. They're probably not going to, get to the top 100 Billboard, but let's be honest, whatever I came up with as a garage band kid wouldn't have either. It's just a completely different way to create art and share, and it's very experimental, but this is like the next thing that I'm working on. The idea being, in order to generate more music, you'll have to spend kale in order to do it. So you've got your kale farmer over on the one side, and then you're making gens and collecting gens and trading gens with your friend, and maybe the kale asset, in order to collect, you've got to spend a certain amount of kale, or you can own exclusive rights. I don't know. There's all kinds of incredible things you could do. Lots of things that we still need to explore, but this is kind of one of the next big things that I'm working on, especially as I think about Kaletility and adding fun things to do on chain, right? This whole thing will be an NFT that you can trade around, combining the graphic with the lyrics with the actual generated song. So anyway, all of that to say, if you want to make one, fine, but don't swarm it. And if it doesn't load after 24 hours, it's probably, why. We all know why. It's because somebody did too many. But anyway, thank you so much for joining. Hopefully that was somewhat informative. We'll get this posted up on the YouTubes at some point. As people have questions, be sure and let me know. Join in, get some kale. Go play with AI. Most of these AI models, other than the ones that I'm pulling for the songs and the music, these are just Cloudflare AI, so it's very easy to get spun up. You know, they've got like 30, maybe 50 now, different AI models you can play with. So if you're looking to start fiddling around, Cloudflare is now a pretty good place to do that. I mean, there's tons of great places out there now. So don't just use the chatbot. I love chatbots, especially those deep research ones. But as developers, engineers, we should be using these things ourselves and learning how they work. And it's just super fun. All right, have a fantastic rest of the week, a good afternoon, and we will catch you all in the next one.